Good morning, dear students. Welcome back. Today we are going to start one more new chapter, very interesting chapter and also very important chapter in the point of examination and also in the point of higher studies. That is the chapter number 11, Introduction to Trigonometry. First, we need to understand what you mean by a trigonometry. The word trigonometry is derived from the three Greek words tri, gono and metron. We know tri means 3, gono means sides, we can say, metron means measurements. That means a trigonometry is a study of three-sided figures. It is a study of measurements of three-sided figures. So, three-sided figure means what? Triangles. Then we can define trigonometry as is the study of relationship. Trigonometry is the study of relationship between the sides and angles of a triangle. So how we can define a trigonometry? Trigonometry is the study of relationship between the sides and angles of a triangle. Then, so how many sides we can have in a triangle? We have 3 sides and also 3 angles. By using these 3 sides of a triangle, we are going to define the ratio of the sides. By using the 3 sides of a triangle, we are going to define the ratio of the sides of the triangles. We call that as trigonometric ratios. So, trigonometric ratios. Trigonometric ratios of right triangle. So, of right triangle. So, we define trigonometric ratios only in right triangle. So, I am saying trigonometry is the study of relationship between sides and angles of any triangle, but we are defining trigonometric ratios only for the right triangle. Why we are taking only right triangle? Right triangle means right angled triangles. Why we are taking only right angled triangles? We can observe what is the difference, because in right triangle, dear students, we know the side opposite to right angle is called as hypotenuse, and if I take an acute angle here, so we will call the adjacent. Notice these 2 angles are adjacent to this side, so we call this as adjacent side. The side opposite to this one is called opposite side. Means in right angle triangle we have 3 distinct sides. We can name it, but this is not possible in all other triangle. So, an equilateral triangle tagondre we can't differentiate the sides. Again, to differentiate, I need to draw a median of the right equilateral triangle. Then definitely again agutte that divides the equilateral triangle into two right triangles, then we can define the ratios in any one right angle triangle. So allu kuda nanu madakagalla antala, if I have an equilateral triangle, so we can draw a median, then it becomes a right angle. Now we can define the ratios of either this triangle or this triangle, right? But to define the trigonometric ratios, we need to take only right angles. Now we will discuss what are the possible right angles. So we say there are three sides anta ಈಗ ನೋಡಿದ್ವಿ. ಅಂದರೆ ತ್ರೀ ಸೈಡ್ಸ್ನ ಇನ್ ಹೌ ಮೆನಿ ವೇಸ್ ವಿ ಕ್ಯಾನ್ ಡಿಫೈನ್ ರೇಷಿಯೋಸ್ ಡಿಫೈನ್ ಮಾಡ್ಬೋದು. ಐ ಕ್ಯಾನ್ ಟೇಕ್ ಐದರ್ ಎ ಬೈ ಬಿ, ಐದರ್ ಐ ಕ್ಯಾನ್ ಟೇಕ್ ಎ ಬೈ ಸಿ, ಆರ್ ರೇಷಿಯೋ ಮೀನ್ಸ್ ಡಿವಿಷನ್ ಅಲ್ವಾ. ಸೊ ರೇಷಿಯೋ ಮೀನ್ಸ್ ವಾಟ್? A is to m, that is nothing but a fraction, a by m. A is to b or a by b. So ಅದನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡ್ರೆ ಒಂದ್ಸರಿ ಇವೆರಡನ್ನು ಡಿವೈಡ್ ಮಾಡ್ಬೋದು, a by c and second one and third one b by c. Again we can define three more, that is b by a, so c by a and c by b. ಅಂದರೆ by using these three letters we can define 6 different ratios. Now we will try to give names to each ratios. Before that, let me write a right angle triangle. Let me write a right angle triangle and we'll study the right angle triangles perfectly. Then we'll move on to define the ratios. So let me take a right angle triangle ABC. A, B, C, right angled at B. And let me take an angle theta. So this is the notation theta. We will write like this. So this is called as theta. A Greek letter. A Greek letter again. It is the letter to denote the angles. Especially in right angle we have only acute angle. With 90 ಅಂದಮೇಲೆ sum of the three angles will be 180, the sum of the remaining two will be 90. ಅಂದರೆ ಎರಡು ಪಾಸಿಟಿವ್ ಇದೆ ಅಂದರೆ ಇದು ಸ್ವಲ್ಪ ಇರಿಂದ both must be less than 90. ಯಾಕಂದರೆ ಇವೆರಡೂ ಸೇರಿಸಿ 90 ಬರುತ್ತೆ ಅಂದಮೇಲೆ each is less than 90. So we can say these two angles are acute angle. So in right angle we are using the letter theta to denote the acute angles. We read this as theta, a Greek letter, a notation for the angle. Alpha, beta ಎಲ್ಲ ಯೂಸ್ ಮಾಡ್ತಿದ್ವಲ್ಲ, similarly we call this as theta. Now we can observe there are three sides. Here clearly we know the side opposite to right angle. Side opposite to right angle is called hypotenuse. The side opposite to acute angle, is called opposite side, or else we can say this is perpendicular. No, so we can say this is perpendicular or altitude ಅಂತನೂ ಕೂಡ ನಾವು ಹೇಳ್ಬೋದು. Either perpendicular or opposite side, anything. Now we can observe here on this line BC, right angle and acute angle ಏನಾಗ್ತಿದೆ? They are adjacent to each other. So we can say these two angles are adjacent angles because they are sharing an arm. So these two angles have a common arm. So ಇವೆರಡು adjacent ಆಗೋದ್ರಿಂದ we call this as adjacent side, or we can say this as a base. Adjacent side can also be written as base. So in a right angle triangle we have three sides. One is called as hypotenuse, which is opposite to right angle. Opposite side are in a perpendicular side, which is opposite to an acute angle theta. Adjacent side or base is always a line segment which is adjacent to the angles right angle and acute angle. Now by using these three sides, let me define 6 trigonometric ratios. So we are, what do you mean by trigonometric ratios? First let me write the definition. Trigonometric ratios, shortly we write T ratios. T ratios are the ratios of two sides of a right triangle of a right angle triangle, we can say right angled triangle. So T ratios or trigonometric ratios are the ratios of any two sides, ratios of any two, we can say any two sides of a right angle triangle. So already we observe, we can write there are 6 possible ratios, we can write maximum of 6 ratios. We given some names for that. So first one is called as sine of. We are defining the trigonometric ratios to the sides with respect to what? The acute angle. So we are defining the trigonometric ratios of any two sides of a right angle triangle with respect to, we can write like this, Baker, with respect to acute angle theta. Then, so we call the first ratio, we given Greek letter words we are going to use here, sine of angle theta, or sine of C. Let me write sine of angle C. This is the first one. Next we call cosine of C. This is the second ratio. Third one, tangent of C. Fourth one, cotangent of C. Fifth one, secant of C. We are defining acute angles to this theta, that is angle C. So I am using a ratio sign of with respect to the acute angle C. The last one is cosecant of C. In short, we write sine of C as either sin C. We can write either sin C, but here we are denoting the angle C by theta. We will write simply as sine of angle C or sin theta, both can be written. Cosine of angle C is denoted by cos of theta. Tangent of angle C is denoted by tan of theta. This is cotan or cot theta. And this is denoted by sec theta, SEC, secant theta anta oddtivi. We will read as secant theta, but we wrote only sec theta. So we are denoting by this symbol, but read as secant of theta anta oddtivi. This is called as cot theta or cotangent of theta. Now this is called as cosec theta. These are the notations for these ratios. Now, how we can define a sine of the angle? Sine of an acute angle in a right triangle is the ratio of, sine of the acute angle is the ratio of opposite side divided by hypotenuse. That is, I can write which is opposite side here, AB. I can write sin theta as AB divided by AC. This is the sine ratio. So sine of the angle, sine of an acute angle is defined as the ratio of opposite side and an hypotenuse side in a right triangle. Similarly, cos of the acute angle theta is defined as the ratio of adjacent side divided by hypotenuse. It is nothing but adjacent side is BC here divided by AC. The third ratio, that is tangent of theta or tangent of acute angle C, is defined as ratio between opposite side and adjacent side. It is the ratio between opposite side and an adjacent side is defined as opposite to adjacent. It is nothing but AB by BC. The fourth, cotangent. Cotangent. So cotangent of an acute angle theta in a right angle triangle is the ratio of adjacent side to the opposite side. Is the ratio of adjacent side to the opposite side. That is nothing but adjacent by opposite. So it is nothing but BC divided by AB. Now fifth one, secant of theta, that is secant of an acute angle. It is defined as secant is the ratio of hypotenuse to the adjacent. Secant is the ratio of hypotenuse to the adjacent. So let me write it as hypotenuse to adjacent. So it is nothing but hypotenuse is AC divided by BC. The last one, cosecant is the ratio of hypotenuse to the opposite side of a right angle triangle. It is nothing but hypotenuse divided by opposite. So it is nothing but AC divided by AB. So these are the 6 different trigonometric ratios in a right triangle or T ratios in a right triangle. Pause the video, write down the definition and also the different ratios. Let me repeat the ratios. In a right angle triangle, we can define 6 different ratios called trigonometric ratios. Trigonometric ratios are the ratios of any two sides of a right angle triangle with respect to the acute angle. This is very important, with respect to the acute angle. So there are 3 different sides. By using the 3 letters, we can group 6 different ways. So for all the 6 different ways, we given some names. We call sine of the acute angle, cosine of the acute angle, tangent of an acute angle, cotangent, secant and cosecant of an acute angle. They are denoted by sin theta, cos theta, or sin C, cos C can also be used, but I given the letter theta. I denoted the acute angle theta, letter theta to the acute angle C. So I am using thetas here: sin theta, cos theta, tan theta, cot theta, secant theta and cosecant theta. So sin theta is the ratio of the two sides, that is sin theta is the ratio of opposite to hypotenuse, cos theta is the ratio of adjacent to hypotenuse, tan theta is the ratio of opposite to adjacent, cot theta is the ratio of adjacent to opposite, secant is the ratio of hypotenuse to adjacent and cosecant is the ratio of hypotenuse to opposite. So I hope you wrote it. Let me continue our discussion. Before that, to remember these ratios, we need to do something alva. So there are 6 different ratios. By remembering a single word, we can remember all these ratios. No need to memorize the ratios. Just if I memorize the spellings of that word, we can write all these ratios. What is that word? That word is Osha Chota. The word is Osha Chota. That is OSHACHOTA. So make this the group, 3 letters in a group. We can define, nodi, the letter S. Sine is the ratio of, so yenide OSH first group, ACH is the next group, OTA is the third group. We can see sine, the middle letter SC there, that means sine is the ratio of OH, opposite and hypotenuse. Sine is the ratio of opposite to hypotenuse. Cos is the ratio of adjacent to hypotenuse. Cos is the ratio of adjacent to hypotenuse. And tan is the ratio of opposite to adjacent. Tan is the ratio of opposite to adjacent. Sir, other three? We can observe other three ratios are reciprocal of these three ratios. We can observe here I have opposite to hypotenuse, here hypotenuse to opposite, adjacent to hypotenuse, hypotenuse to adjacent, opposite to adjacent, adjacent to hypotenuse. If I remember these three, we can write other three, right? The word is Osha Chota, that is OSHA CHOTA. So OSH, ACH and OTA. If I remember these 9 letter word, we can write all 6 trigonometric ratios. Right. Now we will group these trigonometric ratios into separate groups. That means I am going to group the ratios. I will call the first group as reciprocal ratios. Before that, let me add one more point in note. We define ratios to the sides, is the ratio of the sides with respect to the acute angle theta. But as theta changes, as the value of the trigonometric ratios, of an angle theta, do not vary with the length of sides and the angle of a triangle. That means, sir, acute angle means sometimes I can take angle 60 degree, sometimes 30 degree, sometimes 70 degree. Sir, as theta varies, right angle, as theta varies. If I take a bigger triangle, sir, smaller triangle, now ಏನಾರು different length triangle define ಮಾಡ್ಕೊಂಡ್ರೆ value change ಆಗುತ್ತಾ? No, the ratio remains constant. The ratio remains constant if we alter the acute angle and also the length of the sides of a right triangle. So this is one very important point. Write down the point. Now let me write some more important points which relates the trigonometric ratios. First one, let me write reciprocal ratios. We can observe there are 3 reciprocal ratios. For sine, cosecant is reciprocal. We can observe opposite by hypotenuse, hypotenuse by opposite. For cos, secant is the reciprocal. We can observe here. And for tan, cot is the reciprocal, opposite by adjacent, adjacent by opposite. Right. Let me write. There are 3 reciprocal ratio. One is sine theta and cosecant theta. These are the one reciprocal because sine theta is always equal to 1 by cosecant theta. We can observe 1 by sine, 1 by opposite by hypotenuse is nothing but hypotenuse by opposite, that is nothing but what? Cosecant. Therefore the first relation is we can write sine theta is equal to 1 by cosecant theta. The second one is for cos theta and secant theta are reciprocal. That means I can write cos theta as 1 by secant theta. The third one, for tan, cot theta is the reciprocal because we can write tan theta as 1 divided by cot theta. So we call these three relations as reciprocal relations. Right? Yes, next I am going to use the next relation, reciprocal relation nodidvi. The next relation is we call co-functions. Co-function relation athwa co-function. First one, we can observe sin theta and cosine theta, that is cos theta. We ille nodi sin cosine, tangent cotangent, secant and cosecant. We call these two are one pair of co-function, these two are one pair of co-function, and these two are one pair of. There are three different pair of co-function. First one, sin theta and cos theta. Next, tan theta and cot theta. Third, secant theta and cosecant theta are the three pairs of co-function. We can say co-function. This is the next relation we can group. So ಒಂದು reciprocal function ಇರುವಂತದ್ದು ನೋಡಿದ್ವಿ, ನೆಕ್ಸ್ಟ್ co-functions ಇರುವಂತದ್ದನ್ನು ನೋಡಿದ್ವಿ. The third relation, I hope you wrote it. Let me erase it. The third one is quotient relation. Quotient relation. We have quotient relations also. The first one is tan theta is equal to sin theta by cos theta. Quotient andre no? Quotient, that means fraction. We can, if I divide sin theta by cos theta, we will obtain the tan theta. Therefore we call tan theta is equal to sin theta by cos theta as the quotient relation. So because illa nodbodu now, from that side, from the figure, if I take the right hand side, sin theta by cos theta, what we have? Sin theta is nothing but what? AB by AC. Cos theta is nothing but what? BC by AC. AC will get cancels and remains with AB by BC. Here what is AB by BC? It is nothing but tan of the theta. Therefore we can call tan theta is equal to sin theta by cos theta as first quotient relation. The second one is we can write cot theta as either I can write cos by sin, I can write that as cos theta by sin theta, or also I can write secant by cosecant also, because if I subtract this cot theta as cosecant theta by secant theta, this can also be written. It's better if you remember in terms of sin and cos only. Cot theta can be written as cos theta by sin theta. Inge nenpitkolli, or else we can write cosecant by secant, that also gives us a cot theta. So this is the next relation. So with this I am going to conclude today's class. Very, very important class to understand the trigonometry. These ratios are very, very important. So in this class we defined the word trigonometry and we defined 6 different ratios, and also the relations in this quotient relation is the third one. Relations in trigonometric ratios na define madidvi. In my next class I am going to take problems on this concept. Thank you.